Today we're going to be solving systems of equations with three variables. This is section 3.5 in the Algebra 2 book. This is a system with three equations and three variables to solve for. We're going to be using matrices just like we did in the previous lesson. Matrix A will be set up with the coefficients for x, y, and z. Matrix B will be set up with the numbers on the right side of the equal sign. In this first example, we have the first equation's coefficients are 2, negative 3, 2. The second equation, 1, 3, 4. And the third equation, 3, negative 1, positive 1. Those are the values that we're going to put in matrix A. Those are the coefficients for x, y, and z, which is what we're going to be solving for. And we have the set equal to matrix B, which is 10, 14, and 9. Now to solve for x, y, and z, you want to do A inverse times B. Take a minute to enter in matrix A and matrix B in your calculator and do A inverse times B to solve for x, y, and z. Should get 2, 0, and 3. Check your answer. Pause the video for a few minutes until everybody gets caught up to make sure you can get 2, 0, and 3. 2 is x, 0, y, 3 is z. When you have a missing variable, a 0 goes in for that missing variable. In this example, we have the x part of the first equation is missing, so we're going to put a 0 in for x. Y is 1, z is 4. In the second equation, 1, 1, and 1. And in the third equation, x is 2, y is negative 5. The z is missing, so you're going to put a 0 in for that z. Those are the values for matrix A. Matrix B is going to be the values 5, 8, and 7. And to solve for x, y, and z, you want to do A inverse times B. Take a minute, pause until you're ready to check your answer. You should get 6, 1, and 1 for x, y, and z in the second equation. If you're not getting these answers, check your matrices to make sure that you didn't forget a negative or you didn't have a number typed in incorrectly. 9 times out of 10, it's a typing error when you don't get the right answer rather than something's going on with your calculator. In the next example, we have 4 equations and 4 variables. Same process. You're going to set up matrix A with w, x, y, z. And then matrix B will be all the numbers on the right side of the equal sign. So take a minute and set up matrix A and matrix B. Check how you've set up matrix A and B with what I've got here on the screen. And when you're ready, you want to do A inverse times B. Matrix A should be the coefficients negative 2, 1, 1, and 0, because that's what z is, 0. On the second equation, negative 1, 2, negative 1, 1. Third equation is negative 2, 3, 3, and 2. And the fourth equation is 1, 1, 2, and 1. So 1, 1, 2, and 1 in the last equation. Matrix B, negative 2, negative 4, 2, and 6. A inverse times B gives us 2, 0, 2, and 0. That's W, X, Y, Z. Now we try a word problem. The caterer is combining chicken, rice, and shellfish to make a gourmet meal that weighs 18 pounds. Chicken costs $1.50 per pound, rice costs 40 cents per pound, shellfish costs $6 per pound. The total meal costs $29.50. Chicken has 100 grams of protein per pound, rice has 20 grams of protein per pound, and shellfish has 50 grams of protein per pound. The total meal supplies 850 grams of protein. How many pounds of each ingredient should we use? First equation is going to be for the number of pounds that the meal weighs. X, Y, and Z all add up to 18 pounds. In the second equation, we put the money involved in it. $1.50 for X plus 40 cents for Y plus 6 for Z equals $29.50. Third equation has to do with the grams of protein. 100 for X plus 20 for Y plus 50 for Z equals 850 total. Set up matrix A and B with these coefficients. Do A inverse times B and pause until you're ready to check your answer. X, Y, and Z are 5, 10, and 3. 5 pounds of chicken, 10 pounds of rice, 3 pounds of shellfish.